I am Prashant from Sri Venkateshwara College of Engineering, third year, 5th sem. Today I am going to explain about an improved transport layer protocol for wireless sensor networks. Wireless sensor networks are a kind of communication networks having independent sensor nodes that form multi-hop and hog network to transfer data. In the past few years, various transport control protocols in wireless sensor networks have been developed and proposed in the literature. In this paper, we have analyzed pump slowly, fetch quickly protocol and presented an improved transport layer protocol for wireless sensor networks. The improved protocol has been analyzed based on various factors such as average latency and average error tolerance, and it is found that the proposed protocol is better than PSFQ in terms of these factors. Introduction. Wireless sensor networks is a self-organized distributed system consisting of one or more base stations, which are usually called sinks, and perhaps tens or thousands of sensor nodes sprinkled in a physical area. Integration of the information sensed through sensors computations on that and wireless communication make the sensor node able to gather physical data, process the data to obtain crude information and reports to sinks. The sink can query the sensor nodes for the more information. WSNs have several characteristic features. The major focus in this paper is on the design of transport layer protocol for WSNs. Transport layer protocols are used to mitigate congestion and reduce packet loss, to provide fairness in bandwidth allocation, and to guarantee end-to-end reliability. However, UDP and TCP transport protocols, which are currently used for the internet, cannot be directly implemented for WSNs. For example, UDP does not provide delivery reliability that is often needed for many sensor applications, nor does it offer flow and congestion control that can lead to packet loss and unnecessary energy consumption. Related work. For WSNs, various transport layer protocols have been designed to address various issues such as congestion control, reliability, or both. A brief summary of the related protocols is provided in this section. STCP Sensor Transmission Control Protocol is a generic end-to-end upstream transport protocol. It provides both the congestion control and reliability by allocating most of the responsibility at the sink. It provides controlled variable reliability utilizing the diversity in applications. Garuda is a reliable downstream data delivery transport protocol for WSNs. It addresses the problem of reliable data transfer from the sink to the sensors. Its design is a low recovery core infrastructure and a two-stage NAC-based recovery process. RTMC, reliable transport with memory consideration, is inspired from pipe flow method and provides hop by hop transmission to make sure all of the segments can be received by the sink with 100% reliability. Analysis of PSFQ protocol. PSFQ is a hop by hop downstream transport protocol which is reliable, scalable, and robust. It uses NAC based low loss detection and notification and local transmission for loss recovery, and it is basically designed for retasking reprogramming application which requires 100% packet reliability in downstream direction. It consists of three properties: pump, fetch, and report operations. The pump operation controls the rate at which data packets are passed into the network. The fetch operation requests a retransmission of the lost packet from the neighboring nodes. Lastly, the report operation provides a feedback status to the user. This way, it provides 100% packet reliability. Message transmission. The pump operation controls the injection of packets into the network. This operation is important in controlling the timely distribution of code segments to all the sensor nodes and providing basic flow control so that the reprogramming operation does not obstruct the regular operations of the sensor network. For doing so, proper scheduling is required for data forwarding. PSFQ adopts a simple scheduling scheme which uses two timers, Tmax and Tmin. The important task of PSFQ is to recover the lost packets very quickly among immediate neighboring nodes within a collaborable time frame. For that, there is a need to provide time buffer. Tmin gives an opportunity to a node to recover any missing segment before the next segment comes from its upstream neighbors. Since a node must wait at least before forwarding a packet as part of the pump operation. Local loss recovery. Sensor node starts a PSFQ fetch operation to do local loss recovery. It is started when a sequence number gap in a file's fragments is detected. Channel impairments such as fading conditions are always corralled in time. As a result, loss of number of consecutive data packets occurs instead of single packet loss. Therefore, PSFQ uses the concept of loss aggregation whenever loss is detected. PSFQ combines loss such that the fetch operation deals with a window of lost packets instead of single packet loss. Sensor node usually has more than one neighbor in a dense network. PSFQ allows different segments of the loss window to be recovered from different neighbors. Shortcomings of PSFQ. Firstly, PSFQ does in sequence forwarding of data packets. For example, if any intermediate node running PSFQ as its transport layer protocol does not have data packet 2 and has all data packet from 3 up to last data packet, then this node will not forward any of the data packet to the next sensor node. In the same manner, other nodes also remain idle until they get in sequence data packet. So this increases the time at which last data packet will reach to the target node. Secondly, there are some drawbacks into the pump and repair operation of a PSFQ. Whenever in sequence data packet arrives, it waits for random time between Tmin and Tmax for forwarding the data packet. Node does not this waiting by setting a schedule. Finally, in PSFQ, same thing as above happens while repairing the data packets. Repairing of a particular data packet will be filed if radio component is busy. As a PSFQ does not reschedule the data packet for forward it ahead. Improved transport protocol. Out of order for forwarding. As we have seen that the in sequence forwarding results in an unnecessary delay, we are proposing out of order forwarding of data packets. We have implemented it as follows. Whenever data packet arrives at the sensor node, it checks whether it is duplicate or non-duplicate data packet. If it is a duplicate data packet, then it will be discarded. Otherwise, node will be store the data packet into its data cache and schedules it to forward it ahead. This is a comparison of average delivery ratio of PSFQ as a function of network size. Conclusion. We have initially presented various protocols available for transport layer in wireless sensor networks. After that, we have presented our view of PSFQ protocol. We provided some alterations to improve PSFQ's efficiency. We have also shown performance analysis of original PSFQ and improved PSFQ. It has been shown that improved protocol works better than original PSFQ in terms of error tolerance and average latency. We have evaluated both PSFQ and improved PSFQ using simulation. We found that improved PSFQ has good error tolerance and delivery latency. Thank you.